In this video, we are going to solve this question from capacitors. The question is two identical parallel plate capacitors are connected in series to a battery of 100 volt. A dielectric slab of dielectric constant 4 is inserted between the plates of second capacitor. The potential difference across the capacitors will now be respectively dash. So there are four options and you have to choose the correct one. So what is the question? The question is that we have two identical parallel plate capacitors, means they have the same plate area and the same plate separation, and they are connected in series to a battery of potential difference 100 volt. Suppose this is the first capacitor and this is the second capacitor. Both are identical and they are connected in series across a battery of potential difference of 100 volt. A dielectric slab of dielectric constant 4 is inserted between the plates of the second capacitor. So initially it is given that the two capacitors are identical, means they have the same plate area. Suppose A is the plate area and D is the plate separation. So the capacitance will be epsilon naught A by D, and it is given that we insert a dielectric slab of dielectric constant 4 in the second capacitor. So now I will completely fill the space between the two plates of the second capacitor with a dielectric slab of dielectric constant 4. So before inserting the dielectric, the capacitance of the two capacitors were same. Suppose the capacitance was C. But when I insert the dielectric slab of dielectric constant K, now the capacitance of this capacitor will become K times of C. So it will be K into C. So C1 is equal to C and C2 equal to Kc. And here the voltage of the battery is 100 volt. And we know that in series combination, what happens? The total battery voltage gets distributed among all the capacitors. So we have to find that how much voltage will appear across C1 and how much voltage will appear across C2. So in series combination, we know that the charge will remain same in all the capacitors. So charge will be Q and Q, and we know that C equal to Q by V, or I can say that V equal to Q by C. So since charge is constant in the two capacitors, so the potential difference is inversely proportional to capacitance. Okay, so if you look at the ratio of C1 and C2, so here what is K? K is given 4, so it will be 4 times of C. So if you take the ratio of C1 and C2, it is C by 4C equal to 1 by 4. So since potential difference is inversely proportional to capacitance, I can say that V1 by V2 will be equal to C2 by C1. V1 by V2 is equal to C2 by C1, because capacitance and potential difference, they are inversely proportional to each other. So what is C2 by C1? C2 by C1 will be 4 by 1. It means V1 is 4 times of V2. V1 is 4 times of V2. So V1 is the potential difference across the first capacitor C1, and V2 is the potential difference across the second capacitor C2. So V1 is equal to 4 times of V2. So if I write that V2 is V, then V1 will be 4V, and the sum of these two voltages is equal to 100 volt. So 4V plus V is equal to 100. So 5V equal to 100. So V will be equal to 20 volt. Okay, so if V is 20 volt, it means the voltage across the second capacitor will be 20 volt, and the voltage across the first capacitor will be 80 volt. So C1 will have 80 volt of capacitance and C2 will have 20 volt of voltage. So in this way you can solve this question.